question. Another interesting question from Jamb. In the diagram given, the hanging mass M2 is adjusted until M1 is at the verge of sliding. The coefficient of static friction is what? You see, from this arrangement, we can see that this string attached to M1 connected to M2. The force that will move this is due to the weight of M2. The weight of M2 is the force that acts on this rope that will drag this. So at the verge of this one sliding, the force provided by the weight of this is actually equal to the frictional force, which is what we call static friction. Remember, static friction is the maximum force that must be overcome before a body can just start to move over another. So at that point where this M1 is at the verge of moving, the force provided or the force acting on it is equal to the weight of M2, which is actually equal to the frictional force. All right, so with that, we have to look at the question and find a way around it. So we have that the weight W2 due to this mass M2 is equal to M2G, and this weight is equal to the frictional force F, because that is the force that will drag this or that tends to move this. Again, the reaction of the weight of M1 is actually equal to the normal reaction R from the surface, which is equal to M1G. Remember that the frictional force is directly proportional to what? Normal reaction. That means F is equal to, when you remove this proportionality, you introduce a constant, which is the coefficient of friction. So we have that our coefficient of friction is equal to F over R, where our F, frictional force, is equal to the weight of M2. So this is going to be M2G, while the reaction is the weight of M1, which is M1G. Here G takes care of G, and our final answer becomes M2 over M1. So the frictional force or the coefficient of friction on this system is M2 over M1. So our answer is what? Option C. I trust you enjoyed the video. Please click the like button and share. Bye.